All right. Hello, everyone. Welcome to our webinar, Engineer the Earth for a Better Future, exploring the geological and environmental engineering programs here at the University of Waterloo. My name is Abby. My pronouns are she, they, and I am an undergraduate recruitment specialist for the Faculty of Engineering. It's my pleasure to host this webinar tonight alongside a few faculty and alumni of these programs. So let's jump right into it without any further ado. Some important reminders. So closed captioning is available by clicking the CC button at the bottom of your screen. You should see this bar, and you can click that CC button if closed captioning would be helpful to you. You can submit any questions that you might have during the session or after the presentation is over using the Q&A button at the bottom of your screen. Questions are going to be answered via typed responses, and as many as possible are also going to be saved and answered out loud during the moderated Q&A portion of the event. So once we're done the presentation, we'll do a Q&A portion. So you can feel free to put your questions in there in the Q&A for us to answer afterwards during the presentation, or you can wait until after the presentation is over. After this webinar, you can also always email engineinfo@uwaterloo.ca with any additional questions that we weren't able to get to or any specific questions to you that you might have. I would also like to do a Territorial acknowledgement. So the University of Waterloo acknowledges that much of our work takes place in the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. Our main campus in Waterloo is situated on the Haldimand Tract, and that's the land that was granted to the Six Nations, including 6 miles on each side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and all of that is centralized within the Office of Indigenous Relations. We encourage you to visit nativeland.ca to learn more about the land that you occupy, wherever you may be joining us from today. As I mentioned, I have some great panelists on the call that you'll get to meet throughout the presentation and also ask questions of after the presentation. That includes our Director of Geological Engineering, Jen Parks, an Associate Professor in the Department of Civil and Environmental Engineering, that's Bruce McVicar, also Christina Lee, who is an environmental engineering alumnus, and Morgan Molyneux, who is a geological engineering alumnus. So you get to hear from all of them throughout the presentation, and you're going to ask any questions that you might have of them during our Q&A as well. All right, I'm going to pass it over to Jen Parks for a little overview of both of the programs, as well as geological engineering specifically.
Awesome. Well, thanks, Abby. I really appreciate you hosting this webinar. And I just want to thank everyone for attending this evening, or people who are going to watch this after it's posted on YouTube. We really think that the geological engineering and environmental engineering programs at the University of Waterloo are great. And we hope that you all apply and join us in the fall of next year in one of these two programs. So before we sort of talk to you more in depth about both geological engineering and environmental engineering, I just want to briefly start by trying to explain how they're the same and how they're different, because they are very interrelated programs. So you can see here on the screen that we've got a blue circle, and in that circle, that's environmental engineering, and it's listing the different fields or different types of jobs you can have as an environmental engineer. And then it's overlapped with the green circle, which is geological engineering. And then it's got a bunch of different fields and jobs that you can have as a geological engineer. And it might seem a little bit confusing in the beginning to kind of look at these two circles and figure out what's going on and what these programs are and how they're connected. And a really simple way that I like to think about it is that if you think about sort of the world that we're living in, if you think about the surface of the earth, so in the world that we're living in, the surface of the earth is, it's literally the ground that we're walking on, and it's the soil and the water. And really the world of environmental engineering is whenever you're engineering or working from that surface of the earth and then sort of up above it. So the surface of the earth, so soil and water, but then going up into the biological world, so sort of flora and fauna, and then going up into the atmosphere and into the air. So whenever you're engineering solutions to problems in those places in the world, that's when you're in the world of environmental engineering. Geological engineering is below that surface of the earth. So it still contains that common connection of the surface of the earth, so that soil and that water, but then also into the earth below it. So whenever you're designing solutions or working or constructing things, and that part of our world, then that's the world of geological engineering. So we have two connected disciplines of engineering, but depending on what the specific problem it is that you're trying to solve, you're either going to be an environmental or a geological engineer. And hopefully by the end of this webinar, you'll understand a little bit more about the differences between these two different types of engineering. And as I'm the director for the Geological Engineering program, which I'm very proud and honored to be the director, I'm going to give you a little bit of the scoop behind what geological engineering is. So geological engineering is anytime you need to know about the Earth when you're designing the solutions to problems or when you're building some kind of infrastructure. So I'm going to use the word infrastructure a couple of times in this webinar, and infrastructure is essentially when you think about sort of like the built world around us. So, you know, that has to do with like roads and buildings and sidewalks and, you know, railways and things like that. Anything that we have as humans have built is infrastructure. And anytime that infrastructure or we need to design solutions to problems that we need to understand about the Earth, that's the world of geological engineering. So what I'd like to say is geological engineering is anytime you have to build on the Earth, with the Earth, or in the Earth. That's the world of geoengineers. And this is a really rapidly growing field, especially as society becomes more environmentally friendly or sensitive. We never want to be harming the world more than we have to sort of live in our world of humans. This is really important for geological engineers, and it's something that they think about all the time when they're designing and doing their engineering work. But also anytime you want to sort of like think about risk and make things safer, and particularly make things safer for us humans, but also the other species that we share the world with, that's also the world of geological engineering. So I can talk a little bit more about what specifically geological engineers do. So once again, this word infrastructure. So whenever we want to design safe infrastructure, that's the world of geological engineers. So take, for example, that we have a world where we are dealing with roads, and that road happens to be at the bottom of a mountain or the base of a mountain. It's really important that first of all, we can install that road or build that road without affecting the mountain. So we don't want to have there be a landslide as we're building the road. We want that side of the mountain to be stable while we build the road, and then into the lifespan of that road. That's the world of geological engineering. Also, right now, the world that we're all sort of like living and building in and working in is a world of climate change. So not only do geological engineers need to make sure that that road is safe, being safely built now, but if we are in a world where the temperature is going to increase or we're going to have more precipitation, we need to make sure that based on the changing climatic conditions that we're experiencing, that that road is going to be safe. And also, while we're building that road, we also don't want to do anything to increase the negative impacts of what we're building on climate change. So climate change is always sort of in the background when geological engineers are working. And to that end, we also need to help to develop energy and natural resources. So although climate change is something we want to, mitigate, and we don't want to have any negative impacts on climate change, we still need to develop resources in order to help drive the green economy as we all sort of live the lives that we do. So if we want to be having everyone driving around in electric cars, then we need to make sure that we have enough of the resources and the elements that are needed to go into the batteries of those electric cars. And right now, a lot of that will have to do with mining in the earth to extract those resources. But we want people doing that work who are as environmentally minded as possible. So we are going to be developing energy and natural resources as geological engineers, but also another big important thing is assessing the geohazard risk that's out there. So I've already mentioned landslides, but also things like earthquakes and volcanoes, and the stability of natural dams can have really negative impacts if those fail onto the surrounding communities. So geological engineers are the ones who are keeping our communities safe. from the natural environment affecting that infrastructure, and then if that infrastructure fails, having a negative impact on the human world around that infrastructure. So when it comes to what geological engineers actually learn in school, so they build up a strong engineering skill set, and then also learn a lot about earth sciences. So you'll take lots of courses to learn about engineering, but as well as the earth itself. A lot of the different programs, or sorry, a lot of the different courses that we have, they'll have lab or field components. So that means not only will you be going to lectures a couple of times a week, but you'll be doing labs, or you'll be outside in the field where you'll be getting a sort of hands-on experiential learning that's needed in order to help bridge sort of that theory that you learn in class with how you actually practically implement some of the design solutions that you're going to come up with as a geological engineer, and to be able to see those geological processes firsthand, so you can then sort of design and engineer in a world dealing with those geological processes. As far as the actual courses you'll take when you're in your undergrad, so once again, you've got that core engineering courses that you're going to take. So that's when you sort of do all the maths and the physics courses, and you sort of build up that engineering toolkit that you need to be able to help solve problems in the natural world. But then you're also going to take those sort of core fundamental earth science or geoscience courses, where you're actually going to learn about rocks, and you're going to learn about how old the earth is, and how you can actually take a good qualitative and quantitative look at the earth, so you can apply engineering principles to the actual earth itself, and actually to engineer with the earth. During your degree, there's lots of chances to specialize. So you'll have to take a certain amount of required courses, but then you also get to take some things called technical electives, which basically you get to pick courses in the area that you're interested in. And within your degree, you can get different specializations. There's 3 different specializations. One's in geology, one's in hydrogeology, so think groundwater, and then the 3rd specialization is soil, rocks, and structures. So those are all specializations that you do within sort of our department, but then there's also broader options that you can do that are within the engineering faculty itself. So you can get an option in AI, entrepreneurship, life or physical sciences, or management sciences. So these are all these sort of bonus or extra value that you can apply to your degree by taking courses that you're interested in, and getting that sort of extra option or specialization on your degree, which is just going to make you a more employable person once you get out of the university. So geological engineers work in a lot of different areas. A lot of our geological engineers are employed by engineering and geoscience or earth science consulting companies. So that would be an example of, maybe a town who wants to sort of assess their landslide risk. They're going to hire a consulting company, a geohazard a consulting company, in order to help them do that. Also groundwater. So it's a really, especially in Southwestern Ontario, it's really important to our drinking water supply. So being able to sort of manage and protect that groundwater is something that geological engineers do, as well as to try to make sure that if some sort of contaminant does get into the groundwater or into the soil, how to actually remediate that, which basically means make it better, so it's no longer going to be negatively impacting the soil or the groundwater. Also, lots of applications to mining and resource exploration. One of our alumnus tonight, Morgan, is in the mining sector, and she'll be able to tell us lots about that. But also certain government positions are things that geological engineers can do as jobs. And we quite often have students go on to grad school as well. So sometimes you'll actually do a master's in some sort of subset of geological engineering. But also you very often get students going into MBA programs. We've had a couple of go into law school, and we've even had one in recent history go into medicine. So really, geological engineering gives you the foundation that you need in order to, help solve problems in the earth. And then really you can use it as a springboard to go on to like higher education, if that's something that you're interested in. And I think that's all for me now, and I'll pass it over to Bruce McVicker to talk about environmental engineering.
All right, thanks, Jen. Hopefully I can do as great a job as that, but yeah, that was really great. So yeah, I'm an associate professor in kind of the water civil engineering side. So I'll tell you about the environmental engineering. So I think of environmental engineering as work at the interface between human systems and natural systems. So these interfaces can occur in many locations, right? The water, if we're thinking about wastewater, they can occur in the air, they can also occur in the soil. And this interface kind of aspect of the work, it gives us really dual responsibilities. On the one hand, we need to protect human health and well-being, for example, from floods or from adverse air quality, that type of thing. But also we need to ensure the resilience and the health of the natural systems on which we depend. And that's a key motivation for this work. So I think, people recognize this. There's an urgent need for engineers to be able to solve some of the problems that we're facing. So climate change and continued resource development are creating problems for future generations. So we saw many of examples of this just in the last year or two. These are just a few highlights or lowlights, if you want. So the Quebec fires got a lot of attention in the US because of those crazy pictures of New York City. Western Northern Canada heat wave, those temperature anomalies were pretty extreme. The dam break in Libya was a sudden reminder, right, of the power of the natural world for that city. And then a slower biodiversity crisis that's been going on for many years, but we need some sort of radical change to put us on a different track, right? And things like the European drought over the last few years, other droughts around the world, and then questions, in our own backyard, like the green belt. How should we manage something like the green belt around the city of Toronto? What's the benefit of having the green belt? Why do we need it, or how can we develop in a sustainable way? So engineers work in these different worlds. So one area is with energy and climate change, thinking about air pollution and the energy of the buildings and the use of energy. So to heat homes, to drive cars, that kind of thing, and be able to think about the cost and the benefits of that energy use. Water resources is a big part of engineering, environmental engineering work. Drinking water, cleaning wastewater, stormwater in urban areas, protection from floods. And then pollution is the problem. So there's pollution control, wastewater treatment, solid waste management, and then also restoration of systems that have been damaged, as Jen was alluding to, right? In the soil, same thing can happen in the water and in the air. There's a need to fix problems that exist. Part of that is modeling. More and more we have big data and detailed models that need to be run to understand environmental systems like atmospheric systems or hydrologic systems. And then we're also thinking about sustainable cities. How do we develop cities with all these different systems that work in a sustainable way? What did environmental engineers learn? A wide range of engineering and natural sciences, as again Jen was talking about. I won't go through them all, but there's chemistry involved, there's physics involved, solid and fluid mechanics. Just a few examples from our final year capstone, which is a 2-term project you work on in groups. You choose a project, you discuss, you find a technical advisor. Hopefully it's related to a real project that's happening in the world that you can come up with some alternatives and then propose a solution and design it. So some examples, I've helped groups with sustainable river restoration, thinking about flood impacts. designing alternate energy and water harvesting strategies for remote communities, wetland design for water quality treatment, and wastewater sludge for generating hydrogen, clean hydrogen, right? So it's a wide variety of interesting projects. Courses, so again, you start very general with, there's another slide here coming up with that shows the kind of common first year. But then upper year, you'll be looking at lab analysis, field sampling courses, environmental modeling, hydrology, hydraulics, air pollution control, design of urban water systems, environmental toxicology, risk assessment. And again, you can specialize as we have different options available to you. So if you're more interested in energy, or if you're more interested in pollution and treatment and control, you can design your program accordingly. And then you can also add options. So if you really want to add an entrepreneurship option, for example, there's the Conrad School of Management Sciences, and you can take some additional electives that kind of give you an advantage or differentiate your degree relative to other students, give you more exposure to that kind of business, entrepreneurship, those types of skills that you might be trying to pursue as part of this undergraduate degree. The areas that people work in are incredibly varied, and it's great to see people go off and develop their careers. So consulting firms hire a lot of our students, energy sector, renewable resources. A lot of people work in different levels of government, green technology, software development, manufacturing, public health, international banking. And then, of course, I like to find the best students and try to interest them in graduate degrees, because there's lots of interesting research to do as well in these areas. Okay. Oh yeah, this is just a bit of an overview of the two programs together that shows some of the common aspects. So why are these programs good? One of them, compared to some other engineering programs, is the class sizes are smaller, so that you will get a good cohort feeling, hopefully, and you'll get to know your cohort quite well. You do have direct entry into the program, so your spot is yours. The co-op is a key component of education at Waterloo. Many benefits, from financial benefits to the experience you get, and also you get to understand what different careers look like before really having to choose them post-graduation. So you can just kind of try them out, and I think that's a great aspect of it. You learn across disciplines. So both of these programs, you're not always with engineers. You have to go out to the natural sciences and learn about wetlands. You have to learn about earth sciences and about different things. We do have a lot of award-winning instructors. We have an emphasis on design principles. So there's even, we're reworking some of these design courses and adding more design elements through the program. And we are integrating lab and field-based learning as part of this. And of course, at the end, you are eligible for a PEng or a PGO if you're in geosciences. The 1A and 1B, that's our short form for your first and your second semester. You come in the fall, and that's your 1A. So these are the courses you would take: chemistry, mechanics, communication, environmental engineering concepts. That's our design course. And then algebra, calculus. So topics you might recognize from high school. You immediately go on co-op. So in the winter, you'll be working. And then in the spring, which is the May to September or May to August term, you'll come back and do your second term, which is 1B. That's mechanics, computational methods, programming, electrical circuits and instrumentation, earth engineering, and calculus again. Calculus 2. All right, those are your kind of common year, and then it starts to diverge after that. Combining theory and practice, we don't want to sit in a lecture all day. So we do have other activities to do. There are labs, and that's important for both programs to get. You can see people getting their hands literally dirty here. This is a design days working on a landfill project. So this is, and then the one thing you see with the happy smiley boat there is the duct tape and cardboard boat design. And we design those things and then we test them until they fail, essentially by trying to tip them over, trying to sink them, and various tests we do. So those are just a couple of the kind of more design hands-on elements. And then there's also some teams you can get involved with. These are not required, of course, but some people get really involved with different things like Habitat for Humanity, Concrete Canoe design team. Engineers Without Borders is a great organization, and the International Environmental Design Competition. So yeah, we're not trying to weed you out as you go along. We are trying to help you. So we have a lot of instructors and people with experience that are trying to help you. So these are some people that you might meet in your first year. So Bob McKillop, everybody knows Bob. David Brush is also very much involved with our two programs. And then others like Rania, Wei Chao, Corey Zarel, Nadine, you'll meet as well. So these people are really helping you, trying to develop some of the skills that will help you to succeed, right? So thinking about how you learn and your studying style, thinking about problem solving, time management is really tricky in your first year. And then just how to prioritize and prepare for exams and communicate various skills like that. There's some student societies that I don't know that much about, but maybe the people coming up can give you more information about them. So I won't talk too much about that here. So let's maybe move on to Morgan and Christina.
Thank you so much, Bruce and Jen, for that overview of our programs. As Bruce mentioned, we're getting into the student experience now. So I will hand it over to Morgan first to talk about her experience in geological engineering.
Thank you, Abby. Hi, everybody. I'm Morgan Molyneux. I actually am a ground control engineer and I live up in Timmins, Ontario. I work at Kidd Operations, which is actually the deepest base metal mine in the world. So we're just below 10,000 feet. So it's pretty deep down there and it gets hot sometimes, but it's all in good fun. I graduated from geological engineering in 2019. So yeah, a little bit of more information about me to come. So that's actually a picture of me underground, but that was when I was working up in Red Lake. So it's kind of a little action shot for you. So I had several different co-ops. I actually had 7 over my 5 years at Waterloo. They ranged from working in consulting all over Ontario. I was a WEEF TA, so that's in the first year, you'll take a concepts course, which Bruce talked about. And I was a teaching assistant with one of our professors, and Christina actually was too. So it's kind of cool that we both were. But with the surveying course and AutoCAD and report writing, and we're kind of your one-stop shop for any questions that you guys have. So that was a really great experience. I also worked in the municipal sector. So I was working for the town of Innisfil for one summer. And then I kind of got into more of my mining related co-ops. So I worked for 2 consulting firms, both in Mississauga, in their mining and rock mechanics department. And then my last co-op, I was able to score a role up in Red Lake, Ontario, which is where that picture was from, at their gold mine. And yeah, that was, I guess, how I kind of got myself into the role I'm in now. I've since worked at let me think. I worked up in Red Lake, then I worked in Sudbury at Ballet Mines, if you're familiar with Sudbury, and then I've worked at 2 mines up in Timmins now. So kind of had my vast experience with the mining industry since graduating, but it's definitely very interesting. Kind of my career aspirations after so many years. I just got my PNG last December, so it'll be 1 year since I got it. My hopes is that I'll get more into a senior role in the ground control area. So if there's ever any seismic events underground or any of the excavations are, I guess to say nicely, but collapsing, we obviously take safety very seriously. So that's when they would send myself or any of my colleagues down, and we would be the first ones there to determine what would need to be rehabilitated or re-supported so that we can make it safe for our workers underground. And I would say one of my top tips for anyone that's thinking about geological or environmental engineering would be on your co-ops and in school. Take advantage of any opportunity that you're given, because you never know where life can take you. I never expected to be up in the middle of nowhere and underground 10,000 feet down. So it's pretty exciting. So some of the things that I love about geological engineering were definitely my co-op experiences. No one can take those away from you. They're forever that you'll have those experiences. So it's definitely, it'll change your life. And that sounds kind of cliche, but it's definitely it's the way to go. And you'll not only learn stuff in the classroom, and then after going for a co-op job, you'll go back into school and you'll say, oh gosh, I learned that on my job. And then it's kind of nice to put 2 and 2 together and then have the bigger picture. I also like that I was able to do both a lot of earth sciences courses and engineering courses. I tried to take any electives or technical electives that I had, and do any and all of the earth science courses. So I saw Jen quite often in my technical electives, which I really liked. And then of course the professors, they were always there to help, along with the teaching assistants, whether it was questions about your assignments or homework or stressing about exams or what your next job will be for co-op. They're just another person you can rely on to get you through the terms. So it was definitely, those were very rewarding conversations that I would have. I also loved the field trips that we would do. So we get to go up into Bancroft. We get to go to Whitefish Falls. We had several outdoor labs, which was, like I said, another thing was hands-on labs, so both indoor and outdoor, looking at rocks under microscopes or surveying or whatever it might be. It's just something different than being in the lecture, and you're able to take what you learn and actually see it in real life. And then for sure, lifelong friendships that I make. I still talk to several people that I went to my undergrad with, and I see them in industry too, so that's really neat. And just to connect with them and hear how they're doing and what's going on in their life. I'll pass it to Christina.
Thanks, Morgan. Hi, everybody. My name is Christina Lee, and I graduated from environmental engineering in 2016. I also stuck around for a master's and finished that in 2019. I work at the region of Waterloo right now as a wastewater engineer. I've been there for about a year now, and prior to that, I did 4 years in consulting at a local to Kitchener consulting firm. A lot of different experiences there. Yes, so I'll start with my co-ops. Unfortunately, I didn't have time to pull any or could find any fun photos from co-op, but like Morgan had mentioned, I was also a week TA. That was a really wonderful role, and I know when I was in first year, I really used the week TAs a lot, just for also adjusting to school, not necessarily for the technical content, but they were a very probably the TAs closest in age and experience to me. So it was good to have them to rely on, and then being able to pass that forward to the future students was also really nice. After that, I was in Toronto. I did building energy modeling related to LEED certification. I worked for a company that was a subsidiary of Tridel. They build condominiums in Toronto. So I predominantly was modeling condominiums, looking at different materials that could be used, and then running the models to look at what a typical building would cost or use energy-wise, and looking at what whoever was asking us to do the review, what the new materials would be using. And I do know some classmates and some folks in classes below me who do that now full time. So it was a fun way to experience that. After that, I went West Coast. I was fortunate to get a co-op with the city of Vancouver. I did water and sewer engineering there. And all of that's done in-house. A lot of that now is done through consultants, so at least for a lot of municipalities. Now, the city of Vancouver was a little more unique in that, and that was really wonderful opportunity for me to look at the whole engineering process from the design aspect, from the surveying aspect, and from the construction aspect as well. I was able to spend a week with the foreman, went around to all of his sites, and learned a lot of practical applications and the practicality of what we were doing. It's one thing to see something on paper and behind a screen. It's another thing to actually be building it in the ground. After that, I went up north to Whitehorse in the Yukon, dipped my toe into the geological environmental realm of mining remediation. I worked for the federal government there. It was a ton of fun. I went back, so I obviously really enjoyed it. I learned a lot. It was focusing more on the environmental aspects, so looking at the water, I guess, that comes out of mines that are abandoned. Water still runs through the adits. There's still the tailings ponds, and we looked at, in this case, because we were so far north, how the thawing of the permafrost, for example, impacted where water would flow over a tailings pile, the waste pile, as it essentially sunk into the ground. So that was one thing that I got to do while I was up there. And then through that, through my boss, actually, I asked him on my second co-op term if he knew anybody in any of the consulting firms up north, because I wanted to try something else, but I also wanted to go back to Whitehorse. And he was kind enough to take me around to, at that time, it was the holiday parties. And I met some folks at Opus, now WSP, and I went back up to work for them in consulting, doing water treatment this time, looking more at the process of treating drinking water. And one thing I really liked about my co-op experiences, and a tip that I do have, is living away from home. For me, that gave me a lot of independence. I'm from Toronto. I went to Waterloo, so they're about an hour and a half away, depending on where you're going. So really moving across the country helped me gain a lot more independence. And I learned a lot of things about myself, like what I enjoy in my free time, and really helped my foundation. And just to try new things. I think that goes along with Morgan's take opportunities as they come, but try new things, because you never know what might interest you. And then what I loved about environmental engineering, I love that we had labs throughout our entire degree, similar to geological environmental engineering had indoor and outdoor labs. That's a good example there of one of the indoor labs that we did, and a device that I've also used in my job when I was in consulting. And then we had outdoor labs, and they were in the fields. You'd go and they'd take a bore sample, and you'd then say what each layer of the ground that they extracted was, things like that, and learning to identify that. We had a course that was dedicated only to labs and lab techniques. That was done in the summer, so the weather was nice. The days were long. We spent 3 hours typically outside learning different things that I have come across in my career. Not necessarily that I'm an expert in, but something that I do need to understand in order to incorporate into design or ask critical questions of. I like that I was able to experience a lot of different jobs, whether it was the sector I was in, whether it's municipal, different levels of government, or consulting, the private companies, or if I did mine remediation, I did drinking water treatment, I did linear infrastructure. I got to do a variety of things, but I was also able to go back and repeat things if I did like that. My cohort, my classmates, I really liked that. I liked my classmates themselves, but I also liked the idea of being in a cohort. It made studying easier. Everybody was doing similar problem sets, and we were able to help each other get through some courses that were a little harder, and then also just people to enjoy your free time with. The professors, I'll also add in the TAs, thanks Morgan, but they really made a difference. I definitely got a good education at Waterloo, and the professors are really, I found them approachable, they were kind, and they were fun. Some of them, if we had long lectures, would play little videos during our breaks just to help lighten the mood and get our brains off the technical educational aspect and things like that. And then I was also part of the engineering society. That's not specific to environmental engineering, but that is a big part of engineering at Waterloo. I was one of the vice presidents in the engineering society, which gave me an opportunity to meet in that specific role students from different engineering programs across Canada in the province, which I really enjoyed. If we talk about it, it is similar to a student council, probably the easiest comparison. And you got to help plan different events within Waterloo Engineering as well and attend those. And I have a lot of friends from that as well. And I think I got a lot of my leadership, a lot of my soft skills came from the engineering society. Definitely time management, organization. And through that, I also planned a national conference, which brought on a whole slew of other project management related skills, but it really helped me grow in the non-technical sense as well.
Great, thank you so much. All right, I'm going to do a few wrap-up items, other ways to connect with us. As I'm going over these things, I encourage you, if you have any questions for any of our panelists, to pop them in the Q&A. We'll be heading into our moderated Q&A session shortly. But first, I'd like to mention our Eng chats. So these are chats with our current student ambassadors. So these are students who volunteer their time to talk with you, our prospective students, and share their experiences in their programs and at Waterloo Engineering with you. So you can be matched with students based on your programs of interest. So if you're maybe debating between geological and environmental engineering, you can meet with students in both of those programs and ask them about their experiences in those programs. So I encourage you to visit this webpage or scan the QR code here to learn more about that program and to fill out that form to be connected with one of our student ambassadors now. I will say we are in exam season currently, so you might need to wait until exam season's over in the new year to connect with a student. But once they're done exams, they will be happy to connect with you. You can also join us on social media to learn more about our community. We post a lot about what our students are getting up to in their co-ops, what research is being conducted at Waterloo, what our alumni are getting up to. So it's a really great place to just see what's happening at Waterloo and what our students are getting up to. So I encourage you to follow us on these channels. We also have a lot of great videos on our YouTube channel, especially. So I encourage you to check out our Future Students playlist on YouTube as well for some more information. You can also, as I kind of mentioned at the beginning of this webinar as well, you can email enginfo@uwaterloo.ca. That connects you directly with our admissions team. So any admissions questions can be directed their way at any time, or if you have any follow-up questions from this webinar, you can direct that to them. And I honestly really recommend that you come to campus, come visit us. So we have tours that happen every week, and you can come get a tour of our campus and see what some of our spaces and what some of those lab spaces look like that they were talking about. And we also have lots of events that take place as well. So our next open house will be in March. So I encourage you to keep an eye out for registration for our March open house and join us on campus and learn a little bit more. All right, I'm going to stop sharing my screen now, and I will invite my panelists to turn their cameras on. Okay, wonderful. So we have a question here wondering what the percentage of sustainability related subjects are in environmental engineering courses. I know we probably don't have an exact percentage, but maybe Bruce, do you have a comment on how many courses there are in environmental engineering that kind of focus on sustainability?
That's a good question. I was afraid it was going to come to me because I don't have a number in my head. I know that we are trying to increase the number. So that specifically sustainability is something that we're trying to build more into all of the classes. In terms of the specific classes, there is a sustainability and environmental assessment course. And I don't know if Christina or Morgan has a comment. It's, I feel like it is changing a bit. Jen, you might also have a comment, but Christina, I see you've unmuted there, so.
Yeah, and I think it depends on the view of sustainability that folks take. Like I think that in my job right now, wastewater is a sustainable field itself. We're taking human waste and cleaning it essentially so that we're able to meet the high standard that the MECP sets so we can discharge it back into the environment. But I think what you said, Bruce, it is incorporated into courses. And I think there's opportunities through student projects as well to incorporate it yourself into assignments that you have.
Yeah, and just to reiterate a lot of what's been said, it is, sustainability, you can think of it as like a design principle, right? Which is in all of the courses, and whenever you propose a design or come up with a solution to a problem, like sustainability is one of the things that you're sort of engineering into your solution, is that it's a sustainable design. So we do have particular courses like Bruce mentioned on sustainability, but I also think it's something that is, pretty much talked about in every course in environmental and also in geological engineering, as it's just a design principle. Bruce, I don't know if you want to maybe say more about that, or.
I'm just going to plug my 4th year course for design of urban water systems, because something that I've changed over the last few years is to take a campus location and we work on a sustainable design for that location. So yes, last year we built drainage models for the buildings and the courtyards and everything, and then so the students were responsible for building a model and then proposing a more sustainable option, because our campus is not actually that sustainable. So part of it is using what's around us to try to make things better. So that's one example. But I know other professors and the students themselves are taking on projects that have big sustainability components to them.
Thank you all. Another very common question that we get, I don't know who wants to jump in on this, I'll just pose it generally. What is the difference between environmental engineering and environmental sciences, and also earth sciences and geological engineering? What's all the difference? Yes, Jen.
Yeah, so I can take that question. So I think, there's a big difference just between engineering and science, and the way that usually in science, you sort of come up with a hypothesis about something, and essentially what science is doing is sort of like testing that hypothesis to see if it can give you a result. Whereas engineering is usually trying to design a solution to a specific problem. And a lot of the time it has to do with, either like physically building something. So, in the case of like, a landslide, like maybe building some like diversion culvert. So like if the land does fail, so it doesn't actually like sort of take out the town at the bottom of the mountain. So engineers are kind of designing those solutions. Maybe the scientists are more involved in thinking, okay, like what is that type of soil on that mountain? And they can sort of like investigate those sorts of answers. But then usually when it comes down to sort of a geohazard risk assessment, how to actually prevent it from that landslide from occurring, and how to mitigate the results of that landslide if it does occur, is more in the world of engineering. So there's a lot of crossover between science and engineering, and environmental science and earth science. But I would say for me, sort of the big difference is that engineers are, they've got this problem like, hey, is there going to be a landslide, and what do we do if there is a landslide? And then they're designing solutions to mitigate that risk, or to help like monitor that slope so they can tell when it is going to fail. I don't know if anyone else wants to jump in there.
I don't know if either Morgan or Christina have an example. From my perspective, I think of when I was working as a consultant. I had done a master's, learned a whole bunch in engineering and natural sciences about rivers and how they work, and but then I was working, and we had a site that needed to be fixed, and so in my head I had all these ideas about how things work and blah blah blah, different scientific principles, equations I can apply. But then ultimately my boss was like, well, what would you do? So he's like, go and design it, right? So that to me was like the engineering moment where you have to sit down and propose something, and it might not be perfect. Scientifically you might want to like research it for 10 years, but as an engineer you don't necessarily have that luxury, right? So I think that's to me that was the one big difference.
That absolutely, that helps me, so that's helpful. And kind of a spin-off of that question, maybe we'll start with Morgan. How did you know or decide that geological engineering was right for you?
In high school, my favorite courses were definitely math and science. And I took a natural hazards course in, I think it was grade 11 or grade 12, and I really liked that. I thought I wanted to be a volcanologist. I was determined that that's what I was going to be. But then I found out there was a lot of physics involved in that, and I didn't mind physics, but I definitely liked other courses over physics. So after doing the co-ops and I guess to get myself into geological engineering, that was kind of my to answer your question, the first part of the question, I guess, was more, I like the sciences, I like the math, I like being outside, and I really like natural hazards. So that's kind of what drew me in. And then once in the course, I I got a little taste of the geophysics aspect. Wasn't a big fan. It was okay, but it wasn't like super for me. And then I got a taste of mining, and that's what really drew me in. It's pretty cool to think. When you're up in an airplane, you can tell you're really high up, but when you're underground, that deep underground, you really don't know how deep you are. So it's a little freaky, but it's pretty cool. It's neat to think of that.
Amazing. And Christina, same question to you.
Yeah, I don't think I decided when I was applying to programs, I applied to environmental sciences and environmental engineering. I didn't know that's what I really wanted to do until grade 12, I think. I'd thrown around a lot of different careers until then. I think it helps that both my parents are engineers, that career path was always known to me. But ultimately, I think it's similar to what in the last question, the answer is, well, I thought about the end goal of what I wanted to do. And I wanted to design, and I wanted to, do that. And I didn't think that sciences would get me there as easily as engineering would. So that's ultimately why I picked engineering. And I think when I initially went in, I wanted to do wetland restoration. It's not what I do right now. But I think along the way, similar to Morgan, I through co-op and through the different courses and just through opportunities that were available to me, I know when I've done school, I wasn't sure what I wanted to do. The job prospects weren't really looking that great. And the professor that I did my 4th year design project with had an opportunity to do a master's with her. And it seemed like a really cool project. And I was able to, and I, wanted to do it, was able to do it. So I did a master's. Figured out, I think, about halfway through that I did not want to pursue academia further. Didn't want to do a PhD, and then ended up in consulting because, frankly, it was one of it was where the jobs were at the time. And then now that's how I ended up in consulting and did a lot of work in consulting. I learned a lot in consulting. I got to work on a lot of different kinds of projects for different kinds of clients, private, public, which was really great for learning. And I learned a lot of different things. And then an opportunity came to work at the region, and I applied and I got it. And I made the switch into municipal. So now I'm able to see projects all the way from identifying a problem, doing some studies, and now going into design and really seeing the construction and then the commissioning and then the continuation of those things, and with more of a single system versus kind of jumping into different parts of that for different clients and different municipalities. So I answered a bit more than just your question, but that's kind of how I got to where I am right now.
That's very interesting. And it's interesting that you mention kind of career opportunities after graduation. That's another common question that we get for any program. And not necessarily you, but if anyone has anything to comment on, what does employability look like when you graduate from these programs? What are the job prospects?
I will just quickly say that I think for the past 2 years at least, that all of our GONs who've been in 4B, so that means their last term of school, the only people that didn't have jobs when they finished school were the ones who wanted to go and travel and not have jobs at the time. So we quite often find that our students end up going back to a co-op employer. We also have companies that come to campus in like January, and they know that we train and graduate great students, and they specifically come to Waterloo for, especially some geohazard consulting companies come and try to meet students to hire them. So I also know that I think about at least half of, if not 3/4 of the GeoEng group that are in 4A now, so they're almost finishing their degree, they'll be done next winter. They already have job offers. So that's a little bit more of a word of mouth thing, and I can't give you like, a percent or a stat, but highly employable is my impression just from what I've experienced for the past few graduating classes. Also very highly paid positions as well. So it's you're going to get a job and you're going to get paid well.
Absolutely. And I will say anecdotal, but they are quite small cohorts. So Jen does actually know all of the geological engineering students. So although it is anecdotal, I would say it's highly reliable.
Yeah, on the Enviro side, I think I don't know everybody obviously that goes through, and there's different fields in my own area. And I know I do get a lot of requests for putting getting in touch with students that might be graduating, because different companies are looking for recent graduates from Waterloo, right? So they are often looking, and my impression is that the students get jobs quite quickly. I know I keep track of mostly the grad students in the kind of more hydraulics field, and I run into them a lot in conferences and whatnot, because they're all one big happy family. People, I feel like the field is not that huge. You'll end up running into people throughout your career at different conferences or at different jobs, and so we definitely stay in touch and stay connected.
Yeah, I know just for mining too, it's a small community. So I've met a lot of people either I've worked with before, or they know somebody that I know, or a supplier I've worked for knows them or something. Yeah, it's a small community for sure. But I would also say definitely work, like Christina mentioned, I think before, but about your soft skills. If you can join any clubs or any teams or any sort of extracurricular just to help with your soft skills, and if you have 20 interviews, that's okay, because the more interviews you do, the better you'll get at them. I know it can be intimidating sometimes, so it's definitely, even if you aren't interested in the job, but you think, oh, okay, should I apply? Should I not apply? Do it, because the worst you can do is just say no. So, but definitely I would apply to any and all jobs. If you can be a little less restrictive on where you are. I know Christina mentioned she went out west and out up north. That definitely helps too, but get those experiences in, because now's the time. It's only 4 months. It's not the rest of your life. So if you don't like it, it's okay. But hey, you never know. You might meet someone there who knows somebody, and then you can get your next job. So yeah, it's lots of good opportunities.
Yeah, all I would add is that I think when I had interviews when I was entering the workforce, it was my network that really helped get my resume on top of a pile, or even through word of mouth. Like Bruce had said, the job I ended up taking, my resume ended up in somebody's hand because they had done co-op there, and I was doing grad school with them, but they weren't graduating yet. So one of his old employers had reached out to my friend and just said, do you know anybody who does XYZ? And a few of us did, and my resume matched it the most, just because of the variety of co-op jobs I had, and I ended up interviewing and getting a job there. So yeah, your network is quite powerful. And I think at Waterloo, as Morgan had said or alluded to, that the co-op is, you meet a lot of people through co-op, and even just through your classmates. It's a great network to build.
Absolutely, thank you. All right, we're nearing kind of the final couple minutes left in our webinar, so maybe we'll just go around, and if you have any final thoughts for students who are in high school interested in applying to environmental geological engineering, what would your kind of final words of advice or thoughts be to them? And I'll leave it open to anyone who wants to kick it off.
I can go first.
Sure.
I would definitely say what sold me is going to the campus, meeting current students, getting their perspective, touring around, getting a feel for the campus. I think that's really honestly what sold me compared to just other schools. So seeing it for yourself, doing a little exploring. But yeah, I think that would be what I would say.
Yeah, I think that's great, Morgan. I'll just kind of follow up on what Morgan said. And, if you are local or around here, even just in Southwestern Ontario, come and visit us. And we're more than happy to meet with you and talk about the program. But if you're not local, just get in touch with us. Feel free to send us emails and ask us about these programs. We love teaching in these programs, and we have some great exceptional students, and we're looking forward to having you join as new great exceptional students. So just get in touch and please ask us anything. There's no silly questions. It's a big change going from high school to university, and we're here to help you make that decision. And yeah, please get in touch and come to any of our events that you can.
I'll just say that I think a lot of stuff is happening at Waterloo. I think it's an exciting campus because, especially in engineering, there's so many different things happening. It's really tough to keep track of, right? So it is a very interesting campus. I feel like it's not like huge, like U of T or UBC, but it's definitely not a small university. There's many different programs, and there's just a wide variety of opportunities, especially through the co-op and and all the research and whatnot going on campus. So come and check us out.
Yeah, definitely visit campus. I think if you're on the fence between programs, definitely look at what courses you could take in upper years. That helped me decide between different programs for sure. And Waterloo, it's a great school. Environmental engineering was a lot of fun. I think engineering in general opens a lot of doors up for people. I think was previously mentioned, I have classmates who went on to be lawyers. I know some other folks who went to get their MDs or their medical doctors now. So it's not necessarily that you're going to be going into engineering, but it's a really good foundation for how to approach life.
Great. Well, thank you all so much. And thank you for everyone who was able to attend tonight. Kind of echoing what Jen said, but do reach out, do continue to connect with us. As I mentioned, we'll be having an open house in March. So keep an eye out, just search up Waterloo March open house and you'll find some details about that. That's a great opportunity to come to our campus, engage with all sorts of people and get a tour. Or you can come any other time, connect with us virtually. We got those ends chats like I mentioned. We do have virtual tour options if you're not nearby. So in any ways that you're able to connect with us, and hopefully we'll be able to see you on campus soon. But thank you so much, everyone, and have a great night.
Thanks, everyone. Have a good evening.
Thanks.
Yeah. Bye, everyone.
Thank you. Bye.
Thanks, Abby.
Thanks, Abby. Thanks, Morgan. Thanks, Christina.
No worries.
Thanks, Morgan and Christine. Nice to see you.